Hi guys, I hope you guys are having a good day. Today we're going to talk about logarithms. Logarithms look scary, but here's the thing. Logs aren't scary once you know what they actually mean. So in this video, I'm going to show you what a log even is, how it connects to exponents, and then we'll go through some of the most important log rules like product, quotient, etc. With some examples. So here we go. First, what even is a logarithm? Well, a logarithm is just an exponent in disguise. So when you see something like log base b of a equals c, it's actually, this is the same exact equation. B to the c equals a. So the log is literally asking, what power do I raise b to get a? So for example, if I have log base 2 of 8, what is the answer? Well, we have to think about it like this. 2 raised to what power gives me 8? That's the answer. So it's a circle. 2 raised to what power gives me 8? Well, 2 cubed, right? Because 2 cubed equals 8. So let's do another example. Log base 5 of 25. What is that? Okay, 5 raised to what power gives me 25? 2. So logs, just think of it like a circle. 5 raised to the second power gives me 25. 2 raised to the third power gives me 8. So in this example, it would be b raised to the c equals a. So it's kind of like a big circle. Okay? So if we're getting a little bit confused, think of it like a circle. Goes left to right. B to the c equals a. 5 to the 2 equals 25. 2 to the 3 equals 8. So logs and exponents are basically best friends. They're just the opposites of each other. That's why, if you're good at exponents, you're going to be really good at logs. So let's go into our first rule, product rule. When you add logs with the same base, you multiply what's inside. Now, what's a base? Base is this little b. So if I have log 3 of 9, the base of this log would be 3. Okay? So that's just what a base is. Now, product rule, when you add logs with the same base, you multiply what's inside. So if I have log b of x times y, this is the same thing as log base b of x plus log base b of y. So let's do an example with real numbers. So if I have log of 2 plus log of 5, using our product rule, this will just give us log of 2 times 5, which is just log 10. Now, this is a really important thing I need you guys to remember. If they give you a log with no base, if they just give you a log 10, it's assumed that the base is 10. Okay? So if they give you a log and if it's just log 100, the base is 10. If they give you log to 4, then the base is 2. But if you don't see a base, it's always 10. Okay, so let's go through another example. Log base 3 of 9 plus log base 2 of 4. So this would be, let me know, take a second, try to figure it out. So if you came up with log of 9 times 4, which is log of 36, you would be wrong. This is wrong. Why? Remember what I said. The bases have to be the same for you to be able to use product rule, right? You have to have the same base. 3 and 2 are not the same, so you can't use product rule. So watch out for that. Okay, so remember, if you're adding logs, you multiply the arguments. And what is an argument? The argument is just what's inside. X, Y, so in this case, the arguments would be 2 and 5. So, if you add logs, you are multiplying the argument. I know it's weird kind of names for these, but you don't have to memorize them. Just remember, add logs, multiply arguments. Let's move on to our next rule, just quotient rule. Pretty much the opposite of product rule. So this is saying if you have log base b of x over y, it's the same as log base b of x minus log base b of y. So when you subtract logs, you divide what's inside. So for example, if I have log of 12 minus log of 4, this would be log of 12 over 3, or sorry, 12 over 4, which is log of 3. Now, remember, super important, the base has to be the same. And do you guys remember what I said? What's the base of log of 12? It would be 10. The base is 10. Anytime there's a log and there's no written base, it's always 10. So, just remember this. Add equals multiply, subtract equals divide. Simple pattern, okay? But let's move on to our next rule, the power rule, or I was taught the K-log rule, like Kellogg cereal. So basically all this is saying, if you have log base b of x to the k, it's the same as k log base b of x. So what just happened? This k just got brought down. Okay? So, for example, if there's a number in front of a log, you can move it inside as an exponent. So, if I have log of 2 cubed, this would be the same as 3 log 2, right? It's the k-log. K-log, that's why it's called k-log. You bring the 3, this 3 that was here, you bring it right down here. It'd be a k-log. Now, for this example, it wouldn't be helpful to do that. So, if you have, let's just do the reverse. 3 log 2, this would be the same as log of 2 cubed, which is just log of 8. So you can do it frontwards, backwards. But this is just the k-log rule. You're bringing this k down to make it k log. So it's super useful for expanding and simplifying logs. And now let's move on to arguably one of the more important ones, change of base rule. So this rule helps when your calculator doesn't have a log base function. So usually on most calculators, they just give you log, so it's only in base 10. But what if you need something in base 2 or base 3 or base 5, whatever, you're going to have to use change of base. So what does that mean? So log base b of x equals log base c of x over log base c of b. Notice the bases are the same. So let's give a numerical example. So if I have log base 2 of 8, and I want to, we know this is 3, but let's say I didn't know and I wanted to do it on my calculator. Well, my calculator doesn't have a log base 2 button I can just type in. So I'm going to change it to log base 10. So log base 10 of x, which is 8 in this case, over log base 10 of 2. So if you do this, if you do it out in your calculator, eventually it's going to become 0.903 over 0.301, which equals 3. We didn't need to do it on a calculator, but let's just pretend. So that's how change of base works. It's really easy. That's how you switch from one base to another base. And personally, I've only ever used it if I needed to type something into my calculator and it didn't have the specific base I was using. But you might use it for something else. Now let's move on to the zero rule. Alright, now if you guys remember, if I, like quick pop quiz, if I give you 100,000 to the 0 power, what would that be? 0. If you said 0, that would be wrong. It would actually be 100,000 to the 0 power is actually 1. Now, it's a little bit confusing, right? We'll do a quick aside, okay? I'll show you guys why. So if I have 2 to the 1, that's 2. 2 to the 2, that's 4. 2 to the cubed, that's 8. Do you see, as we're going backwards, we're dividing by 2. Now, if I have 2 to the 0, why would that be any different? I'm just dividing by 2. So 2 divided by 2 is 1. So that's why 2 to the 0, or anything to the 0, is 1 instead of just 0. So, using that, we get log base b of 1 is always equal to 0, no matter what the base is. So if we go back to our circle, b to the 0 is always going to be 1, right? Like we said up here. Anything to the 0 power is always 1. So if we have log base 7 of 1, this would be 0, because 7 to the 0 is 1. So whenever you see log of 1, your brain should just go 0. We're done. Move on to the next question. Okay, next rule, reciprocal rule. This is a really quick one. We can use quotient rule to prove this. So log base b of 1 over x is the same as negative log base b of x. So if we use quotient rule, right, it would be log base b of 1 minus log base b of x. Now, like we just said, 0 rule, we know this is 0 immediately, and this would just be log b of x, which is just negative log b of x. And there it is. So this is a simple one. Now, let's put this all together, the end. So if I have log of x plus 2 log of y minus log of z, how do I do this? Our first move, we're going to use k-log. K-log. So k-log, I can move this k back over here. So what's that going to give me? I'm going to get log of x plus log of y squared minus log of z. Great. Now I'm going to combine the pluses. So now I'm going to get log of xy squared using, what rule did we just use? Product. Sorry, it's a little bit messy, guys. Product rule. And then just minus log of z. Last rule. What are we going to do? Quotient rule. Log of xy squared over z. Boom. Fully simplified. So you see this huge equation up here, 3 terms, just became this little baby thing over here. So that brings us to the end of this video. So if this helped you finally understand what's going on in math, get you a little bit more comfortable with logarithms, drop a like, subscribe, and thank you guys so much for watching. If you have any questions, put them in the comments. If you have any videos you guys want me to make, put them in the comments. Thank you guys so much for watching, and I'll see you in the next one.